All right, let's go ahead and get started. So welcome everyone. We're so happy to have you here today. My name is Tennille. I work in the Plano Public Library system, and I'm glad you're joining us for STEAM Skills Coding and Circuits. Your microphones have been muted and videos are turned off for this program. We have a rather large group. It's gone between 180 to over 200, so it's very difficult to have everyone be able to speak at once or to be able to show, okay? We're just doing this to manage our webinar better so that all of you can have a really good experience in learning today. Please note that if you have any questions, you can type them into the chat. We will be monitoring the chat to assist you with any issues. Any relevant links for the program today will also be placed in the chat. And today we have the honor of introducing the Society of Women Engineers. SWE stimulates women to achieve full potential in careers as engineers and leaders, expand the image of the engineering profession as a positive force in improving the quality of life, and demonstrate the value of diversity. SWE will present the STEAM Skills 5-week course, and we're on week 3 on coding and circuits. Today, the topic will be C++ programming with Mera, Aditi, and Pike. Okay. Housekeeping reminders that we would like to share with everyone today is that we don't solicit any business or sell merchandise during the library virtual programs. That is prohibited by the city. Please be respectful and considerate of each other and your presenters today. If we have any inappropriate commentary, behavior, it will result in the removal of you from this webinar. I will now hand it over to my presenters.
Hello guys, so give me a second and I'll share my screen. All right, welcome to week 3, Introduction to C++ Programming. Today's table of contents is what is an array? Here today we'll teach you what the definition of an array is, how to use it, how to make an array, and more. In our second section, we'll go over for loops, which you learned in the last session, and how to use them with arrays. And section 3 would be just helping you guys practice what you've learned so far. Yeah, so, and of course, towards the end, we'll have a short Q&A session in which we'll just show you, we'll answer any questions you have or clear any doubts. So let's start section 1. What is an array? An array is a data structure in the computer's memory. It consists of a collection of elements, each identified by an index. I know that sounds kind of complicated, so let's simplify it. Think of an array as a set of lockers in your school hallway. Each space serves as a memory location for some data. In each locker, you can put your backpack or your books, and you have access to your backpack and books anytime, right? And then each memory location has an address. Think of how your locker is located in a specific hallway. It has an address. When you think of your locker, you're like, oh, it's in D hall, and I have to walk down D hall and go down a couple of steps, and I see my locker, and then I can open my locker and grab any books I have. And each space has an index. So think of your locker number. You know that when you go down D hall, you walk down a couple steps, your locker number is locker number 50. And the indexes are always in sequential order. They start from a small number and go up higher and in increments of 1. So you can think of how you have a locker number 1 and then it increases and you have locker number 2, locker number 3, and so on. And all these indexes must always be non-negative integers. And I mean, sure, you've never heard of a locker number -3 or 5.6, right? So yeah, that's basically how an array works. Okay, so arrays in C++, some general rules. All the elements in the array are of the same type. All all of them have to be either integers, all of them either have to be characters or strings. You can't have a mixed array. You can't have integers and strings in the same array. Second rule, you do not need to declare each element of the array separately. You can have 5 integers declared as an array without having to name them all. Like you don't have to say integer number 1 and then add it to the array. You could directly do it right. You could do it right here, like how I've done string fruits, apple, kiwi, banana. I didn't have to declare apple separately as a variable or kiwi separately as a variable, or so with banana. I just put them all in the fruits array at the same time. Third rule, you can access data at certain memory locations through the indexes of arrays. So here I have an array called nums, and it's an integer array, which means this array will hold only integers. And nums is the identifier of this array, or the name of this array. And we know that this array will have 3 elements because this is how we give it the length. So this array is an integer array called nums and holds 3 integers. And over here, we've assigned each index of the array an element. And so the first index, 0, oh yeah, I should probably specify that arrays indexes always start at 0. Unlike when you count, you usually start at 1, but when you count indexes of an array, you have to start at 0. That's like a programming rule in any language. It could be Java, C++, Python. Array indexes always start at 0. So at the first index at 0, you've assigned that space an element, and that element is an integer 13. And the second space in the array, you've assigned at index 1, you've assigned 25 as the integer element. And then the third and the last position in the array, you've assigned element integer 46. That's how, and when you have to access these memory locations, you can do it through the indexes. So right here, you see num0 equal 13. Then here we've created an integer called sum, and we're trying to add all the elements in the array to sum. And for that, of course, we need to access what we stored in the array, right? So we say num0, and right here, and num plus num1 plus nums2. And basically, we're just substituting these values. So right, num0 should hold 13, nums1 should hold 25, and nums2 should hold 46. Okay, so I will run this for you and show you this. So right here, you can do this. This is the part we'll be running. And when we run it, it compiles. And you should see that it should give you the sum 84. And this is one way of doing it. You could also do this. This is the exact example that we showed in the slides, and this works too. Gives you 84. And remember how I was talking about how you can't, you don't need to assign variables to each element. You can directly add them into the array. So here I've tried to assign each element a separate variable name, but that is just unnecessary and you don't have to do it. It'll still work, but it's so much more work. You have to write 3 lines of code just to add 1 element, whereas over here, you could add all your elements in 1 line of code. All right. Here, so now we talk about how you actually go about making an array. How do you add elements to the array? How do you initialize these elements? There are several ways to initialize an array. The default initialization is where we only declare the array and none of the elements in the array are set to any particular value. So when we declare an array, and set it to default values, the computer automatically assumes that all the elements in the array just have 0. You haven't assigned them any numbers yet. So over here, how we said int num5, this is an array of integers called num, and it has 5 elements in it. And none of these elements within these curly braces have any numbers in it. So all of these values would be 0. And remember how I said array indexes start at 0? So this is 0, our first element. This is 1, the position 1, our second element. Position 2, our third element. Position 3, our fourth element. And position 4, our fifth element. So it has 5 elements, but 0 to 4 indexes. And now if we try to explicitly initialize our array, as in assign each element a value when we declare the array. The explicit initialization is where we give each element a specific value when we declare the array. So for example, right here, we said int num5. So this array is an integer array called num and has 5 elements. And we've initialized all these 5 elements with the declaration. So within these curly braces right here, you can actually tell the computer that, oh, so I want my element in the 0th position, or the first element, to be 16, and my element in the next position to be 2, and then 77, 44, and then 12,071. And that way, your computer knows that, oh, so this the user has given me the values that I need to put in each of these positions. So this is what your array would look like. And one cool thing about C++ is that you don't have, if you initialize all the elements in the array, you don't have to give it a length. You don't have to tell it that, oh, there's 5 elements in my array, here they are. You can just say, here's my array, and these are the elements. And then the computer would assume that the length of the array would be the number of elements that you have provided. And then the last way of doing it, the number of elements in the curly braces cannot be greater than the number given in the square brackets. So the number in the square brackets is basically how many elements you want to put in your array, right? So if you have 5 elements in the array and you told the computer that, you cannot give it 6 or 7 elements, because then you'd be going against what you told the computer. So the number of elements that you initialize has to always be less than the length of the array. So right here, we said int num5. This is an array, integer array called num, and has 5 elements. And this works because it has less than 5. So any position, any positions that you have not initialized, like position 3 and 4, it would automatically assume that it's 0, because the user did not provide the computer a number to assign it. So it'll assign all the first elements, and anything that's left would be 0. But right over here in this example, int num5, and then I have 6 or 7 of these here, but that is greater than the length of the array, so it won't work. Okay, accessing elements in an array. Array elements are accessed using their index. We write the name of the array, then its index in the square brackets. So when you have to access an array, a specific element in an array, you do it this way. So remember the array called nums. So right here, you say the name of the array, and within the square brackets, you say the position you want to access. So this would mean you want to access the element at the 5th position, at index 5. That would be the 6th element, because remember, arrays start with index 0. So the index 5 actually holds the 6th element. Same way here, if you have an array named ARR and you want to access the element at index 7, you would be trying to get the 8th element in the array. And then same way with locker. And the index could be a variable if the variable has previously been given a value. the variable must be an integer and contain a non-negative value. Like we said, you don't find lockers that have a negative number. There's no locker -3 or locker 5.6, right? So they have to be an integer and they must be non-negative. That means 0 and up. And here's an example. So you can say integer mynum equals 7 and nums is mynum. So this would just substitute whatever the value mynum is. So here we know mynum holds the value of 7. So when we call this statement nums mynum, it would just substitute this 7 into here. And then you would access the element at index 7 in the array nums. And like I said, they have to be integers and they have to be non-negative. So here we say double mynum equals 3.4, and we can't do that because 3.4 is not an integer. And here we say int mynum, but our integer is -2. And like we said, no non-negative values, so that doesn't work either. All right, so I'll pass this on to Maida from here.
Great, thank you. So I'm going to be talking a little bit more about arrays and for loops and how we would use for loops through arrays. So if you can go to the next slide. Before we kind of talk a little bit more about for loops, I do want to do a quick revision because I see a lot of people have questions about what exactly is an index and what exactly are they trying to store. So I just want to do a quick revision before I go into for loops. As you can tell, so indexes are used within an array to kind of keep track of the values that you're storing. So for instance, we would always start off with the index number of 0. So it would go 0, 1, 2, 3, 4. And we typically like to set a limit to the number of values we like to hold just to make sure that we're able to store enough memory that is needed in order to make room for all the values we want to store. So you can even store 1,000 values if you wanted to, but it's always good to make your code efficient. So because of that, we like to set the maximum number of space we might need. So in this example above, we have an index from 0 to 4. So basically the size of the array that we're going to be storing is a size of 5. So it's going from 0, 1, 2, 3, and 4. And so because of that, the first value that we're going to store at an index of 0 is 2. And then the next one will be 4. And then after that, it'll be 1, 3, and 5. So those are some of the specific values that we're storing within each index size. So before I kind of talk a little bit more about for loops, I just want to make sure you guys clearly understand what an array is. So please let me know if you have any questions about that. Okay, so with that being said, I guess I'll talk a little bit more about, okay, so Vian said that the numbers are jumbled up into the values. So that is correct because you can store different numbers. So you can even store 108, for instance, in index 2. The values don't really matter, but the index order does matter. So just keep that in mind. But great question. So with that being said, I really like the analogy that Pollock used. So you're almost storing all of these different values in a locker, right? But what if you want to actually retrieve the information from that locker? How can you retrieve a particular instance, right? And that's where for loops come into play. So for loops are used when the times a block of code needs to run is known. So if you need to know, for instance, the value at index 2, you would run a for loop to try and figure out what the value of index 2 is. So for loops can be used to print the array values and also helps assign values to an array. So you can print out a certain value. So you can print out the value of 1 for index 2, for instance, or you can even assign this value to be in that specific location or place within the array. So to go through an array in code, an index variable can be used to keep track of the position in the array. And the way that we would go through the whole entire array is we would increment. So we would increment from the 0 position index to the 1st position index to the 2nd, 3rd, and 4th, and so on if you have more indexes. So an example of this is through this first line, for int I is equal to 0, I is less than or equal to 4, and I++. So this line is showing us, so we're starting off with an index of 0, because that's our very first value. And the maximum number of values we have goes to an index of 4. So that's why it'll go from 1 to 4. So you're basically initializing or setting the value of the first one, the first value, and the last value. And through I++, you're incrementing by 1. So you're incrementing from I is equal to 0, and then you go to I is equal to 1, then I is equal to 2. So you always add 1 every single time. So that's what the incrementer is used for. So that's a great question, Hima Chandra. So what exactly is an incrementer? So kind of think about it as going upwards. So you're trying to go to an index, that the very next index. So I bet you all know addition, right? So 0 plus 1 is 1, right? So it's going, oh, I'm so sorry that I called you the wrong name, but Harsha, I hope this really helps you out. So 0 plus 1 is equal to 1, right? So you're going upwards, or you're going to the next index by 1. So you're incrementing by 1. So you're going more upwards. So that's why you go 0 plus 1, and then 1 plus 1, and then 2 plus 1 to go through the whole entire array. So Geetika asked, what if you wanted to increase a number greater than 1? So let's say that you wanted to go from the first value all the way to I is equal to 2. You could do that. So you could do I is equal to 0 plus 2, and you can get to the value of the second index in that process. So you can increment in whichever way you want. But I think typically in a lot of programming and coding segments, you will see that they like to increment by every 1. So just something to keep in mind, but I hope that kind of clarifies some of your questions. With that being said, if we can go to the next slide. I know that I kind of talked a little bit more about several ways that we can use it, either to print certain values or assign certain values. So as you can see, there's a coding segment to print an array, and there's another coding segment to assign values. So I'm actually going to now share my screen to showcase ways to print out a certain value. So I'm going to share my screen. Okay, so can everyone see my screen? Yes? Okay, I'm gonna assume that y'all can. And the first step that I would like to showcase is we have the main function. So within this whole function, so a function is kind of used to enclose some of the code that you're trying to program and run. So we have to first initialize or set values within our array. So we have an array that we call numbers, and we're storing different values. So we can assume that 2 is in an index value of 0. So the value 2 is going to be stored in an index value of 0. Then 4 is going to be in an index value of 1. Then 1 is in an index value of 2, and so on and so forth. So this is where we initialize our array. Once we initialize our array, we can get any value we want. So what if we want to print out a value? What if we want to print out the value 3, right? I'm going to ask you guys a question. Which index is the value of 3 stored in? Can someone tell me a response to that? Okay, let me check real quick. I'm assuming that, okay, I see 19 chat, exactly. So it is in index 3, exactly. Good job. So now I'm going to say we want to get the number 3. So in that process, we're going to go with the index of 0, 1, 2, or 0, 1, 2, 3, exactly. So now through this for loop, we're going to try and retrieve the number 3. So we're going to print out. So C out always stands for printing out a certain number. So we're going to C out, and then we're going to try and print out the value 3. So as we run it, which I'm going to run, let me see if, let me scroll down real quickly. Okay. As you can show, it's going to be printing out all the numbers till the value of 3. So it's printing out the first value, the first value, which is 2, then 4, and then 1, and then 3. But if you want to print out all of the values, we would include an index value of 4 because that's the maximum amount. And as we run that, we will print out 2, and then 4, then 1, 3, and 5. So we print out the whole entire array. Does that make sense? Okay, so I'm gonna see if there's any questions. Cool, it makes sense, great. So with that being said, that's an example of how to print out values from an array, right? But now I'm going to show you a different example. So I'm going to show you an example of how to first assign a value to a particular array and then print out that value. So unlike the prior example, the way that you initialize an array is slightly different. So rather than including all of the values that you want to store for the array, you just have to dictate the maximum size that you want the array to be. So in this situation, they're expecting the array to have a maximum size of 4. So with that being said, we will have a for loop. So rather than just printing out the value, through this line over here, we're storing a particular value. So we're taking this index value and we're stating that we want that value to be, for index 0, to be 1. Because as you can see, in this first situation, I is equal to 0. And if you try and add 1, you get 0 plus 1, which is 1. So we're stating over here that we want the value of the first index of I is equal to 0 to be 1. So as we go to the next value, which is I is equal to 1, what are we expecting the value of that to be? Okay. So we would want the value of that to be 2, because 1 plus 1 is 2. So it keeps on going like that, and we can assign a value and then we can print it out. So let me just run this real quickly. And as you can see, we get 1, 2, 3, 4, and 5. So we get an index value of 0, and we're doing 0 plus 1, which is 1, and we're printing that out, right? Once we print that out, it has to go through the whole loop again, and then you have to do I is equal to 1. So you do for the For the next value, you do 1 plus 1, which is 2, and you print that out, and then you have to go again. So you have to do this until you get to a size of 4. So that's why you're able to go from 1 to 5. So with that being said, I kind of shared a little bit more about what arrays are and how you can use for loops to get any value. So with that being said, I guess I'll turn it over to Aditi to showcase the activity that we have planned.
So I can assume that you guys can see my screen. Hello. So
yes, we can see your screen.
Okay. So hi, my name is Aditi. I'm gonna be teaching you section 3, basically activities. So we're gonna try to find a lucky number that is computed especially for you through what we learned today, arrays and for loops. So okay, so if you guys can go ahead and open the link right here, the GDP compiler, so that we can go ahead and program together this thing. So I'll wait for everyone to open it. The link is in the slides at the very end. Oh, can someone share the slides? I also send the link in the chats. So I'll wait for everyone to open it, then we'll get started. So I'll get started now. So when you open the link, you would see this. So it's basically gonna say "see out hello world." That means that it's just printing out and showing that it's working. So I'm gonna remove that and start with first, we're gonna write an array. So to define an array, we were gonna do, it's gonna be an int array, int variable type array. So we're gonna put int, the name of the array that we want, square braces, and then we're gonna define the values. So it could be anything if you want 2, 3, 4, 5, 1, 6, 7. So one more. You can make as long as you want the array. I'm gonna minus from 0 to 7, which means 8 containers. That's gonna store the value, the data. Now, so we know that it's from 0 to 7. To let the computer know that it's from 0 to 7, we're gonna use a function that's provided us by C++. It's called size of num. So we're gonna just put the num, the name of the array there, and divide that by size of int. So this will give us the exact size of the array, which is 8, when we're gonna try to print. So if I print this out right now, see out, count, and run, it's gonna print 8 because we have 8 different values here that increment from 0 to 7. So 0, 1, 2, 3, 4, 5, 6, and 7. So this is working currently. No. So to find your lucky number, this is just a normal formula that we're going to use to find a lucky number. It doesn't really define that it is your lucky number, but this will help you learn the concepts much better. So we're going to initialize lucky number equal to 0 for now, because we have to find your lucky number. So we're just going to initialize it to 0 for now. At the end, it will show it to you. And then we're going to take 2 data in. So it's basically your age. So for me, I'm 20, you can put 20. And then the time you look up. So you're just gonna put your age and time depending on yours. You can put different numbers if you want. And then we're gonna start with a for loop. Int I equals, since we want to run it from 0 to 7, we're gonna use the size that we already found out earlier, which is count. So this thing, so we're basically telling the for loop to start from here, and then that's not equal to count right there. So, and this code is written in the slides as well at the very end, if you guys need help. And then this is where we're gonna try to find your lucky number. So we're gonna do plus equal num. And I is the thing that we're gonna use for counting the indexes. So right here, so since this number 2 index is 0, 3's index will be 1, 4 will be 2, and so on and so forth. It'll keep going, and by incrementing by 1. And the indexes are non-negative integers, so it has to start from 0 and increment by 1 each time. And then we're gonna print out your lucky number right here. So now we're gonna do so this is where it's adding things. You can leave this here. You can also put it right here, over here if you want. And then we're just gonna print out the number. Cout. If I run this now, it's gonna show my lucky number, which is 28. So if this works so far for you all, I'll give everyone to type it. I'll leave the screen open. And if you're done typing, any questions? No, you don't have to put the yellow brace if you don't want to. This basically means it's a comment, so the compiler or the computer that's running it on, it'll just skip that specific line out when it's running. So size of int, this is a problem with C++. So in C++, when you're trying to find a size of an array dynamically, like so we are given this array and we don't know what the size is. We can have like a big array, 10,000 values, 11,000 values. We are not sure as user. So if we want to find the specific number of how long that array is, the C++ has given us a function that is size of. So we're going to put size of num. But the problem is if we take out this part right here, it'll give us the size of the whole num. So the array size is 32 bits. So that's what it's going to print out. But we need the size of the array that we initialized, which is 8. So to get that, we would have to put the thing size of int. So the size of number divided by the size of int would give us the exact size of the array that we made. So that is why we need the size of int there. you have to declare your age. On these slides, I know it's left as blank right here, but just type in any number. So just remove that and type in your age like that in the compiler and it will work. Yes, the loop only runs one time because we need the lucky number. We only have one lucky number, so we wanted to run it just one time with for loops. If you want, you can loop it. If I remove count here and put 0, it's gonna go from 0 to the count, which is 8. And if I run this, it still gives you the same number. If you want to do it, your lucky number is, so right here at this line, see out at the end, see out less than a lucky number. You can just put 2 more less thans and like that. Your lucky number is, and if you run that, I'll show you your lucky number is 28, like that, if that's what you want. For in return 0, do you have the semicolon and add the braces at the end? So that could be an error. Yeah, I can paste the code in here. Just a minute.
Aditi, you're on mute. I'm sorry.
Sorry. So if you want to take in user's input, basically instead of see out, what you will do is see in. So you can just do here see out, right here. So see out, type in your age, and then we're gonna do see in. So you're gonna do see in. There. Initialize this to a 0. And if I run this, it's gonna ask me for my age. So I type in my age and then it's gonna show my lucky number if that's what you want. And if you also wanted to take your int time you woke up, so basically what you'll do is see out and ask and this the thing type in the time you woke up today, right? Like that, semicolon, and then you can do cin time you woke up, which is the variable name, int variable name, put that 0. So we're gonna initialize that to 0 and run. So it's gonna ask me for my age, time I woke up, and it's gonna print out my lucky number if that's what you want. If you press debug, press stop. So if I press debug right here, so if you're gonna press debug, then you can just click stop, and then it'll stop the function, and then you can run it again. Right, like that. Any other questions? If you all are getting error at cout or cin, just make sure you have this line here at the top. If that's not there, it's also fine. You can just put std and 2 colons like that, and that still works. So it still works the same way. So we're using cin function, and if it's asking you to type something in the console, so when we're using cin, it basically means that the computer wants us to type something in the console to get the value in the variable your age. That's why it's asking you to type something if you're using this code. Okay. If we're done with this, then we can have a whole Q&A session with everyone. I'll stop sharing my screen then.
Hi all, and thank you so much Aditi and everyone. It's been great. We're gonna do Q&A in just a moment. I'm just gonna present a few short library resources, then we'll get straight back to Q&A, okay? All right, and I will share my screen. All right, let's see. Can everyone see this? It's look good, everyone can see it?
Yes.
Okay, thank you. All right, so again, my name is Tennille, and I'm a librarian here with Plano Public Library System. We're definitely more than books, okay? Things that are relevant that could support you in different kind of STEAM topics, curriculum, content, including what we're doing today with coding and circuits, are things like STEAM kits that we offer at the library. They include learning components for science, technology, engineering, arts, and math to support STEAM-based learning, okay? Teen STEAM kits focus on technology and problem solving. You can check out more STEAM kits on the Plano Public Library catalog, planolibrary.org, or you can come in person to take a look at our listing of them and see what they offer. We also have our 3D printing, which is pretty awesome. They're available at 3 libraries, Davis, Harrington, and Parr. You can use 3D design software programs like TinkerCAD to design your own model. For more information on how to submit your 3D design and 3D printing classes, check out planopubliclibrary.org, okay? Or come in person to one of those 3 libraries I just listed. So LinkedIn Learning, this is a great database that you can access with your Plano Public Library card. If you don't have a Plano Public Library card, you can just bring a guardian in with you if you're under 18, and we can get that for you in about 10 minutes. Very easy at any of the library locations. You can check out courses on LinkedIn Learning for Arduino, TinkerCAD, C++, what we're doing today, programming, and more on LinkedIn Learning. Access LinkedIn Learning on the Plano Public Library under Research and Learn. Okay. We really appreciate you coming today. Thank you so much to our presenters and SWE as a whole for making this accessible for us. This is an amazing course. And remember, we have 2 weeks, 2 more Wednesdays after this week to complete your course, okay? I'm going to stop sharing my screen and I'm going to turn it back over to our presenters so they can have a question and answer session for you. All right, if you would like to ask a question, you just raise the little hand that you have in Zoom. We won't be able to get to everyone. We have 141 attendees, but we will get to as many as we can, okay, in the next 10 minutes or so. All right, okay. All right, I'm gonna start with Rachel here. All right, Rachel, if you're ready, you can go ahead and speak. And you have to take yourself off of mute. Oh, maybe I need to do that. Let's see. Okay, so I'm asking you to unmute and you can go ahead and do that. So Rachel, you can go ahead and put your question in the chat since for some, oh, here we go. Go ahead, you're unmuted. You muted yourself. Okay, so let's go to Mujib. All right, Mujib, you just need to take yourself off of your mute so you can speak.
Yeah, hi. This is Mujib's dad. He just stepped out, but he wanted to know what is the logic behind this, the loop that was used in the code.
For the lucky number code?
Yes.
So there wasn't really any logic to it. We just wanted to make sure that they know how to use it, the loops. It's basically, there's nothing to do with it. We're just showing them how the int-array thing runs with the loop and how it works. Basically, each array element has, so if for the loop, basically if you just put number I without the loop, so it will just print one value. But if you use it with the loop, it'll print all the values. But in this case, we really didn't have any idea to use loop, but we wanted to show them how loop work as code wise. But there wasn't anything with it, the loop and lucky number thing.
Okay, gotcha. Thanks.
All right, let's go to Ms. Swati.
Okay. Can you hear me?
Yes, ma'am.
Okay. Do you see the I++ thing in the 24th line? Why do you have to use that?
So I++ is basically like an incrementer. It basically means I equal I plus 1. So we're just taking the I value, adding 1 to it, and then putting that value back again in I. So for arrays, so suppose you make an array that from 0 to 4, so 5 elements, right? So you make 1, 2, 3, 4, 5. That's the data stored in the array. But now if you just take, so suppose you want to print an array. Now, if you just put num I, like cout, num I, and semicolon, it will just take the first value of the array and print that out. But now, if you want to print out every single value in, you're gonna have to use a for loop. And in for loop, it's for loop is structured. Basically, you have a starting value, you have an ending value till which the loop will run. And then to go from that starting value to the end value, you have to increment each time. So I++ is basically just a breakage that when it reaches 5, so it goes from 0 to 4, and if it goes 4 plus 1, which is 5, 5 is the ending statement. So it'll basically end the loop and exit the loop out. So that's why we need I++.
Yeah, so why do you have to put 2 pluses then?
It's just the way the code goes, I guess. So you just do I++, or if you want, I can just show you the different way as well. Let me just share my screen. Share.
Okay, Ms. Swati, I'm gonna mute you so she can show you this, and also so we're able to have a few more people speak. Okay.
Okay. Thank you.
So here we have I++ right here. If you just take this out and do equal I plus 1, this is similar to doing I++ right here. So if I run the same thing, all the same stuff. So it's just doing the same thing. I plus 1 is similar as I++. Also, you guys might be getting confused here as well. So this is basically, if I take this out, so this is basically what it's saying. You do this. So that statement, having lucky number plus equal num I, this statement is similar to this. It's just that we're just putting a plus before the equal. So it's basic, since we're adding in the lucky number, so programming language give us that benefit that you can just use this plus and equal and add in to the value since we're using the same variable type. So if that makes sense. Stop sharing.
All right, let's go on to Prithvi here. All right. Mr. Prithvi, are you with us?
Yes. Actually, when we were doing the lucky number code, the screen was actually black.
Your voice is very low. Can you speak more closer to the mic?
Yeah, can you hear me now?
If you just speak up just a little bit, we could probably hear you better.
Can you hear me now?
Yes, ma'am.
Okay, so when we were doing the lucky number code, I wasn't being able to see like the screen that was sharing because it was actually black.
If you want, I can just put the code in the chat. I'll just do that.
All right, so let's go on to Rishika. Rishika, you're off of mute now. You just take yourself off and you can speak if you have a question.
Yeah, my question is, so why do we have to put semicolons at the end, and do we have to put semicolons at the end of every line of code?
That's a very great question. You can go ahead, Paul.
Okay, yeah, so semicolon is basically your way of telling the computer that this is the end of the line. And because if you don't tell the computer that my line ends here, the computer is going to get confused and the computer is going to be like, I don't know where this line ends, or is this the same line as the previous one? Am I supposed to do these two things at the same time? So every time you have a line of code, make sure you end it with a semicolon before you start a new line of code. So for example, in the lucky number code, every time you define or declare a variable, like when you say int lucky number equals 0, you have to end that line with a semicolon because the next line is a new variable. So to tell the computer that that particular variable is done and over and it's been defined, and you're starting a new variable, you have to end the line with a semicolon. So int lucky number equals 0, semicolon. Next line, int your age equals 20, semicolon. So that the computer knows that you're done defining it and you don't have anything to add on.
Okay, thank you. Thank you.
All right, looks like we have just one more. Mr. Mujib, did you have another question? You can go ahead and unmute yourself if you have another question. No? Is there anyone else who wants to raise their hand to have another question before we leave? And we do have one more question in the chat, which is, can you send the link to the presentation? We can go ahead and put that in the chat for you again. Thank you. Thank you. All right, if there are no other questions, I hope all of you have a wonderful afternoon. Thank you again to all of our SWE presenters for an amazing course. And please don't forget to check out our library resources and to check out your next Coding and Circuits course next Wednesday, again at 3 o'clock. Okay, have a wonderful day. Bye.